Hi, this is János, it's Real World Audio, and today it's going to be epic. So Neil O'Brien asked me if AI could be used to design us a 2-watt single-ended triode amplifier with simplest possible circuit and minimum number of parts. So I got really curious myself and asked ChatGPT to explore the subject and provide me with a circuit and ideas how to build a 2-watt single-ended triode amplifier. And you see here ChatGPT, and I use the 4o model, which is the current new model, to give me ideas on how AI would be going on to designing a 2-watt single-ended triode for us. And let's see. So that was my question there to the prompt: can you design a 2-watt set amplifier for me? And then this was the answer. Designing a 2-watt amplifiers involves several key considerations, including a type of the amplifier, example Class A, Class AB, or Class D, power supply, output impedance, and specific application. This is absolutely right and correct. The AI missed one thing here, that I already specified set, which means single-ended triode, and AI didn't understand the concept of set. So that's why it put Class D in it, because yes, there are single-ended designs in the transistor or solid-state domain, but the T means triode and it means vacuum tube. So we are Class A or Class AB, or maybe Class C in telegraphy operation, but certainly Class D is not the answer for this. Let me know if you'd like to design to target audio use, radio frequency, or other purpose, and here are specific constraints, and there are specific constraints you'd like to use. So here is a basic outline for a 2-watt Class AB audio amplifier design, and it gave me an idea for components for a solid-state Class AB 2-watt amplifier. And I'm not going to go into detail on that. It also gave a breakdown for the components and about a circuit diagram as well, what it would involve and what would be in there. And then I clarified my prompt for AI: can you make it a vacuum tube amplifier with vacuum tube rectification? And now it said, it recalculated its response and said that single-ended Class A and what tubes, and it said preamp tube, for example 12AX7, and power tube EL84 or 6V6. So that's what it gave as a recommendation. And for rectifier 5Y3GT or 6X5GT. And output 8 ohms and power supply 250 to 300 volts DC for plate voltage. And so far this sounds alright, and there's no big flaws in it. And but I would say like a 12AX7 with an EL84, that's not a match I would do. I would build the 12AX7 is a little bit too much gain for an EL84, but for a 6V6 it's a better match. But still, I think probably it was AI's first choice, because that's the most frequently used driver tube, and power tubes, yeah, these are two of the most popular, some of the most popular tubes ever. And these rectifier choices are very cheap rectifier tubes, and the plate voltage is right what we would need for these power tubes, and it's also usable for the 12AX7. And it says high level design. I'm not sure what that means, but there we go. Input stage preamp, and that the terminology is not correct that AI uses, because yeah, that's the input stage, but it's not a preamp. In this case it's the driver, the tube that drives the power stage. So anyway, so it's not entirely clean on what a preamp is and what it is, but it defined input stage properly. Use of 12EX7 for voltage amplification. Nice. Include a coupling capacitor to block DC and allow signal transfer to the power stage. Again, got it correctly. So so far so good. Power stage. Use an AL84 or 6VC in single-ended configuration. Yes, that's what we wanted to see, and that's what it's recommended. Very nice. Bias the tube in Class A operation using cathode resistor for self-biasing, and that's very nice. And this is the simpler way of building, of creating the bias for the tube with cathode resistor. This is self-biasing, another name for that. And here we need only a single resistor to self-bias the tube, and we can bypass it with a capacitor. But the other alternative is a fixed bias, but that would add, I would say, significantly to a minimal complexity tube. And also my addition to those of you who are interested in designing your own amplifiers, cathode resistor, I think it sounds a lot better than fixed bias. And what people say about fixed bias, why they prefer to use it, because it gives more power. But fixed bias doesn't give you more power. You get only more power when you have the same B plus voltage, and that's because for the self-biasing there's a certain amount of voltage that's dropped over the cathode resistor, and that's why the plate voltage for a self-biasing tube is lower than the plate voltage for a fixed bias tube. But if you increase the B plus voltage to have the same plate voltage for a fixed bias as you have same plate voltage for a self bias, then the output power of the two is equivalent. So the reason that to use a fixed bias to have higher power when you are a DIYer and you build your own is a nonsense, because then you just increase the plate voltage to have that higher power, and you can have exactly the same amount of power. You can even have higher power than the fixed bias if you increase the plate voltage of the tube in comparison to that circuit that you originally started with. Anyway, that was just a segue about self-bias versus fixed bias. Power stage. Use output transformer to match impedance of the tube to the low impedance of the speaker. Yeah, it's good. So it gives us an explanation why it chooses certain things and why you need things. And I think that's a great idea, because so far so good. It's largely good advice. Somewhere it's confusing, like why is it called high level design? God knows why, or maybe AI knows why. And why is it calling the input stage a preamp? That's also confusing. And then power supply. Use a tube rectifier to convert AC to DC. That's great. Add filter network with capacitors and a choke to smooth the rectified DC voltage. Perfect. So that's so far so good. 4. Chassis grounding and shielding. Ensure proper grounding to minimize noise and hum. Perfect. That's also very important. Now, detailed circuit, preamp stage, which is the driver stage or input stage. Plate resistor about 100 kilo ohm, which is, yeah, sounds good for a 12AX7. That's a great start. Cathode resistor self-biasing here as well, 1.5 kilo ohm, bypassed with a small capacitor about 25 microfarad. That's also good advice. Coupling capacitor 22 nanofarad to 0.1 microfarad. It's on the smallest side, but yeah, it will work. And then Power stage, EL84 plate resistor. This is tricking a beginner DIYer, because we are not using plate resistor for the power tube, we are using output transformer, and here it says use primary winding of the output transformer, but it doesn't says instead of the plate resistor for the power tubes use it. So I think this is kind of confusing how it's written, but it's technically correct if you know what he's talking about. Cathode resistor 200 to 300 ohm for self bias. Yep, it will 6v6 or an EL84 will work with that. Output transformer rated for 2 watt with a primary impedance of 5k, secondary impedance 8 ohms. Yeah, that will work. However, good luck finding 2 watt rated output transformers. Probably I would recommend like a 5 watt rated output transformer. Maybe you can find a 2 watt. It will be super cheap, super expensive, but probably not very good sound quality. Such transformers are really built for like a ultra budget and not for sound quality. I have not really seen any single-handed output transformer made for quality purposes which is less than 5 watt. So that's something that you would know when you are an experienced builder, and even though AI has access to all kind of lore out there, it does not provide that information for us. It's just picked something. Power supply circuit rectifier, for example 5i3 GT, and input high voltage, example 250 250 from the power transformer. So that's a center tapped transformer, and that would work. That would give us approximately a little over 300 volts DC. Output rectified DC with initial capacitor, for example 10 microfarad, and an LC filter choke and capacitor. Very, very nice, very good suggestion. But I would say that well, let's go. What else does it say? Filter network capacitor 47 microfarad after the choke for smoothing. Now this is kind of confusing, because this, what it refers here, is the same thing here, and it kind of didn't tell us that it's talking, the filter network is this choke 10 Henry for filtering ripple. So this is this choke that it talks about. So, and then the output 250 to 300 volt DC for the amplifier. Well, yes, actually that's what you would need for these power tubes, for this circuit, but using this transformer that it recommended, you will get, even with this tube, something like 320 volts, and you would say, yeah, that's close enough for 300 volts, but it's saying like between 250 300 volts. If you design your circuit with 250 volts in mind and you feed it with a 320 volt supply, you are going to cook your tubes well and truly, and your amplifier will work, yeah, but you are running it so hot that your power tubes will either fail very soon and you will see smoke coming out, or if not, probably within a month or so your power tubes will reach the end of their lives, and certainly if run like that, your amplifier will remain a fire hazard. So here it got us some generic knowledge, but did not put it in a way that it's good for someone who is beginner. So if you are a beginner and you want a 2 watt single-handed triode amp, then AI is not the way to do it, because it doesn't have any consideration any of the refinement that would make it safe, that would make it practical. And it has like parts there collected for you, but you have to chew it and put it together. And then example schematic. Here now it gets more curious. If you want, I can create a visual schematic for this design. And then would you like? I said yes please, and this is what it gave it to me. As you say, this is it has kind of the elements, and I know what it wants because I know how schematics look like. But if you want to build it, then this is garbage for you. It's totally unusable. But if you already know how to design a schematic like that, then you can draw your schematic and just reorganize these elements to make sense out of it. But this is so oversimplified that this is just massively inadequate to be called as a schematic based on which you could build an amplifier. I would call this as the first stage of doodling, or like a draft version 0, and it's a good starting point to develop a schematic based on that. So the description it gave for that was basically including 12AX7 preamp stage, power stage EL84 with self-bias and output transformer, and rectifier stage 5x3 GT with a filter network, capacitor, choke, another capacitor. So basically when we go back, you see it uses the 250 volt center tapped power transformer, but this is talking only about the high voltage supply. There's no mention about the filament supply at all in here, and there's no mention about the input. This circle is supposed to be the tube for the driver tube 12AX7 with 1.5K cathode bias resistor, and the plate resistor should be here. And then the 47 microfarad, I don't know what that is. I think that's probably on the high voltage. That should be the filter capacitor for an extra stage after the power stage to decouple the power supply for the preamp. And then what else do we see? It doesn't make sense why it is written there and as plate resistor with the power tube there, because that shows like there's the output transformer with the power tube, but it's mixed up with the description for the plate resistor of the input tube. And then there's like the 47 microfarad, that's supposed to be the filter capacitor for the power supply, and it's kind of written where you should have the cathode bias resistor for the power tube, and there it mentions 300 ohms, so that's the cathode bias. So it kind of like it has no idea how to draw a clean schematic. It has the lines there, but elements are put at the wrong part. There's like the output transformer there, but how does that connect to the power supply? The 47 microfarad, the last filter capacitor, is shown after the output transformer. It should be preceding the output transformer. The choke is missing from the description. The rectifier is missing from the. Well, actually, it says rectifier here, but how is it hooked up to the power transformer? It gives us no clue. So that's why I said this is just a draft version 0. And it said, let me know if you would like a more detailed version, specific part values, or any adjustment. Yes! So when you want AI to design you something, it's really interactive, and I noticed, because since ChatGPT came out, I've been experimenting with it, using it, trying out and seeing what does it know about subjects, and And that's what I noticed, that when you want to know about something, then you ask questions to refine what it says. And if you don't get what it wants, you can also tell it like, can you recalculate the answer, give me another answer, and then it will give you a different answer to the same question, and then you can choose like thumbs up or thumbs down if you liked or not the answer, and then you also can give it comments, what you liked, what you didn't like, etc. And I added, yeah, can you also simulate the circuit, please include operating voltages and currents and transformer ratios as well. And then it says like, I won't read this aloud, I don't want to take time for that, but anyway, it gave a little bit more details. So input from the rectifier, no, at the power supply, it's input for the rectifier. So the causality is mixed up. So this is coming from the transformer, the 250 is going from the transformer to the rectifier, and the DC output voltage that's 300 volts after rectification and filtering. And yeah, kind of, if you put like a really high DCR choke, then that could go down to 300 volt, but it's still a little bit higher. I would say it will be about 320 volts, because let's see, let's get a calculator up here. So like a 250 volts times 1.4, so that would give us like a 350 volts DC if we are using maybe like 340 or 345, if we are using the 10 microfarad input capacitance that it suggested. Let's take out like from 10 to 30 maybe 20 volts for rectifier drop, and then another maybe 10 volts for the voltage drop at the inductor. So like minus 30 volts will have 320 volts DC. So kind of like 300 volts, but that actually does make a significant difference. 300, 320, that's like almost 10% difference, and you might think 10% is not that much, and I can tell you, yes, tube designs can handle easily 10% differences, but if you build your tube design to be maxed out at 300 volts, to have running your tubes at 100% plate dissipation at 300, then adding the 10% significantly shortens the lifespan, and you would think that the vast majority of commercial tube amplifiers have been designed by AI, because a lot of them are running like that. People are running most of the power tubes at 100% or over 100% capacity, and that's why there's the generic problem that people have the impression that every 6 months you have to change your power tubes in a power amplifier, in a tube amplifier, because after 6 months you already notice that the sound quality is degrading, because the tubes are approaching the end of life. And not because that's how tubes are, that's how bad designs are. But that's what sells vacuum tubes, and of course modern tube manufacturers, that's what they want, that they every year you buy several sets of power tubes, and that makes them money. If you buy a set of power tubes and you need to change it every 5 or 10 or 20 years, then who's going to buy all of those power tubes? Who's going to supply constantly loads of money to those plants? So that's why things happen the way they happened. Now preamp stage 12AX7, plate voltage about 200 volt, plate current 1 milliamp, that sounds okay. Cathode resistor 1.5K with 1.5 volt on the cathode, that sounds right. Power stage, plate voltage 250, plate current 40 milliampere, class A operation, cathode resistor 300 ohm for a 12 volt bias voltage. Now this sounds right. That's kudos. Well done, AI. Output power about 2 watt into an 8 ohm load. Yep. Actually, the output power, it will depend on the output transformer, because the lower the primary impedance of the output transformer, the more power it can provide to your speakers at greater distortion. The higher the impedance of your power transformer, the less power it can put out, but at much lower distortion. So that's why with power tubes, tube amplifiers, you have the choice as a designer whether you want more power or you want a cleaner output, and that's where it comes in. And it's not just this, but in real life, this is your method that you can match a loudspeaker to an amplifier by trying out different primary impedances and see which synergizes the best with the loudspeaker. And that's why when you have a specific tube amplifier with a specific output transformer, it will synergize really well with certain loudspeakers and won't synergize at all with others, because the distortion spectrum and the power delivery spectrum will match certain speakers better and will not match other speakers that well. As a designer, you have the choice to play around with that and find out what your speakers like, or just pick one of your preference and then find the right speaker for your amplifier. Now, of course, we have this problem that it suggested that the power stage has a 250 volt plate voltage with a 12 volt bias, so it means that we have a 262 volt design, and let's go for the 262 volts, and we had, what was that, 320 volts minus 320, so 58 volt is the difference between the operating condition of the tube and the actual voltage that the proposed power supply provides for your tubes, and that's like about 60 volts higher than 260 volts. Now that's a lot. Yeah, so like 60 divided by 260, that's 23% over voltage. Now that's a lot. So this will and eventually, if you look into it and like what is the wattage, like let's make a calculation. How hard are we running the tube here, or how hard AI proposes to run it? 250 volts times 40 milliamps. So let's go back here. 250 times 40, that's 10 watts of plate dissipation. So this tube is rated at 12 watts. So it means that we are running it below 100% plate dissipation. So even if we add a little higher voltage, higher plate voltage, higher plate dissipation, it will be still fine. However, for how fine we'll be doing, let's see. So at 320 volts, actually for this tube, that's a little higher than the maximum recommendation for the tube. Let's see, 320 volts times with the same cathode resistor, probably it will be around 45 to 50 milliamps plate current. It will bias there, let's say 46 milliamps, and then it's almost 15 watts of plate dissipation divided by 12. So like we are at 123%, 122.6%. So we are 22% over the maximum plate dissipation for this power tube, and we are also about almost 5-10% above the maximum plate voltage, which is 300 volt for the tube. And if you know about power tubes, let me just show you what I'm talking about. Here you go. This is like the a data sheet for an EL84, and you see it has like typical characteristics: 250 volt, limiting values, which is the maximum you can use, and it says UA. It means the plate voltage, anode voltage maximum is 300 volt, and WA, that's the power, 12 watts, so it means 12 watts anode dissipation. And IK, that's 65 milliamps right here. It means the anode current, 65 milliamps anode current. So you need to take these three values into consideration when you are choosing the operating points for a vacuum tube, and it means that these are the maximum values, so you cannot go higher than them. So, but yes, you can. So it means that if you design it and all of these values are this much or little less, then your tube will operate optimally and have a life expectancy that's provided on the datasheet. If you put any or all three of these values much lower than specified here, then your vacuum tube's life expectancy is going to be exponentially longer at the cost of exponentially less power output. However, you can exceed any of these values if you take the other two values much lower than that single value. So for example, you can exceed the plate voltage, which the AI recommended to exceed the 300 volts by approximately 320 volts. Okay, from 320 we take away the self-bias voltage, which is probably something like from the 12 volts it increases to 15, so 305 volts. It's not much higher, it's kind of hovering there, but it leaves no wiggle room, so it means that if it's a little bit higher, then the IK has to be a lot less than 65, and yes, AI recommended 40, so that's a good compromise. And also because it was expecting that we only have 250 volts on the plate, it gave us like something like an 8-9 watt plate dissipation, but in this circuit, in the power supply, it miscalculated the size of the power supply, the output voltage of the power supply, and instead of the 12 watts, the plate is dissipating 15 watts. And now that's not good, because what is happening here is that we are exceeding 300 watts by 305, and we are exceeding the 12 watts by 15, and that's like a major thing. And yes, you would say, okay, 305, 300, whatever, close enough, but the plate dissipation is something that really you cannot really exceed without punishment. If you are exceeding the plate dissipation, it's going to decrease tube life a lot, because the tube is unable to get rid of the heat. You are cooking the tube alive, and that the cathode current is a little less is not going to help, because these two values, the voltage and the plate dissipation, are maxed out and way beyond max out. So this operating point is not good with this supply that it recommended. What you could do is increase the cathode resistor to have even less current, less than 47 milliamps, drop it maybe to 35 milliamps or 30 milliamps, and then bring that down, the dissipation down to below 12 watts to, I would say, 11 watts or so. Especially if we are exceeding the plate voltage, we are keeping it like super high, then my recommendation is don't go for 100% plate dissipation. Run the tube a little cooler, and then it will love it. And probably if we adjust this maybe like 600 ohms or so, then it will bias to something like that. That's just a vague approximation. It will kind of work, but with this setting so far, you will just manage to cook your power tube like the Thanksgiving Day overbaked turkey. Output transformer, this is good, 5K 8 ohms, and that will work. My choice for an EL84 for really high quality output would be an 8K primary inductance, and I would make it in a way, because it said, I think it recommended it as running it in triode mode or pentode mode. I don't even recall it mentioning about that. My recommendation for a single-ended amplifier using EL84 as an output tube, to get an output transformer that has an ultralinear tap and put in a switch, so you can switch between ultralinear mode and triode mode. And when you're in a triode mode, put a 100 ohm resistor in there, so there's a 100 ohm resistance between your plate, the anode, and the grid. You could also use, which is even better, like a Zener diode, like a 6 volt Zener diode, 6.2 watt Zener diode. And why is that important? Because then your screen voltage is a little bit lower than the plate voltage, and you must always keep the screen voltage a little lower than the plate voltage, because the screen is a lot more fragile than the plate, and that will significantly lengthen tube life, and also will have an impact on the sound. Will be noticeably better, less stressed sound. Anyway, current sufficient for 50 milliamp draw for amplifier stages. Now here it forgot to mention that the rectifier tube, this 50 milliamp draw, that's per channel. So up to here it was okay, what you would think. I haven't specified it's stereo amplifier, but as a human being you would always know that, hey, I want a stereo amp, right? We are living 21st century, right? But here from the current draw, it tells us that it's only calculating for one channel, so we would need about 90 milliamps for the two stages. Operating points and voltages, it kind of went, oh, it says, look at that. Here it now has clarified that the screen voltage is through a screen resistor, so it's like in a triode mode. Yay, thank you. It's not making it obvious, and but it says connected to the power supply through a screen resistor. Now, what this means is that it's in pentode mode, so not connected to the anode, that would be in triode mode. Connected to power supply, it means pentode mode, so it suggests us that it's running in pentode mode. And I would guess that an EL84 single-ended in pentode mode, it's a bit more than 2 watts. I think like 3, maybe 3.5 watts of power. In triode mode, it would give us a little over 2 watts already. I think 2.5 watts easy of an EL84 with a 5K load in triode mode. Yeah. Anyway, approximately 2 watt fine. But no, with pentode mode it would be a lot more than that. It would be like 3-4 watts. Transformer 5K. Okay, now I wanted to ask it. Here it comes totally crazy, that I asked it because it was suggesting I can do simulations, whatnot, but can you redraw the schematics? The lines got jumbled up in the presentation. Can you make out the connections and descriptions? Oh, where is it? Now I've skipped through to the bottom. I wanted to see if I asked it more questions. So we have asked at the very beginning. I mean, we went to the line of my end of my inquiries. So let me scroll down, but this is going to be the big shock. So far AI did pretty decent of drawing us a 2-watt single-handed triode amp, even though it's not typical. It's a single-handed pentode amp in a triode mode. Yeah, good enough, close enough. All right. But here, when I asked it to clarify the schematics, now it got totally bonkers on me, because let's just scroll back. I'm scrolling back. This is what it drew as schematics. Let me just show it in a bigger picture. And it's like, where are we? What is this? Look, this is pure fantasy fiction, has been absolutely removed from reality. It is just an image that it generated. It's complete pulp fiction. Look at that. This doesn't make any bloody sense in any universe. It's completely fictional. It's using elements from designs, and it's created absolute pure pulp fiction fantasy. And even the descriptions make no sense. Like here it says Kupi.nis Coppatours. Like you can guess that it took coupling capacitor and it created some garbage text with that, but this doesn't look like a coupling capacitor. It looks like a vacuum tube's glass bulb, and you see the top mica layer and the support layer, all the tube legs, the two pins there, and there's like something that looks like a transistor in the middle of it. Like, what's that? And here there's like a PRSHI mode. This doesn't make any sense, but it looks like a transistor in a glass envelope with a broken button, and that looks like they're like a resistor with one band marking only in a very strange case going nowhere. It says platte, like plate, but fudged up, and that looks like a sub-miniature vacuum tube with an X and on it, and the anode structure is just completely fictional, and there the support structure inside looks like total fantasy. And here, when you look at this big tube here, that's supposed to be where the rectifier tube is, right? If you think that the 12AX7, why is it 7? Let's say this was your input tube, and now 2-watt vacuum UOE APACOM. What on earth is that? A84? That's some doodling based on EL84. Okay, that might be then what the power tube should be. Then this should be what the rectifier should be, and what is written on top of it is like something that wants to be output transformer. It's output transformer. What on earth is that? It's just complete doodling nonsense, and it has a vacuum tube instead of a transformer drawn there, and it has like the support structure, like broken support structures, the wires that should be like feeding the filament, and the anodes, they are broken there, some are missing. You have some wires going into the tube through the glass bulb. It makes absolutely no sense. These are not how vacuum tubes are. It's just completely a complete fantasy. And I think that's why we have to be really, really careful when you want AI to design an amplifier for you or anything that you want to use purposefully, is because it sometimes gives you like really it makes you think that it really knows what it's talking about and giving you some good advice, and you think, yeah, it gets it, and then when you say, please go into detail, that schematics, if I take this as a basis to create my schematics, I can use it as a starting point, and it gives me some ideas for starters what I will need there. But when you want, okay, now provide me in detail, and it tells you that the AI GPT-4o have not the vaguest freaking clue about what an amplifier is. I just have an endless amount of information at my disposal, and I have zero control over knowing what of this part of this information makes any sense, what is practical, and what is pure fiction. And that's what I have noticed when dealing with AI, is that sometimes not just sometimes, often it is an excellent source to dig information from the internet. And it's kind of like typing in queries in Google and you want to find stuff. AI can find that a lot more efficiently for you, but it does not have any brain capacity, any intellectual capacity or experience to parse that information and find which is relevant, which is someone just typed in a forum like a trolling message, and you might get the trolling message as the source for you or the data to use, and so it has a very limited capacity to give you what you need, and sometimes it doesn't get certain concepts. So for example, I noticed when I was looking about I really never asked audio stuff from ChatGPT before, because I was really skeptic what it wants, what it can do with it. But I was asking it a lot of time about camera stuff, information on cameras, like for example, list me the pixel pitch of these cameras, and then it was much faster than looking up each camera's sensors, what is the pixel pitch of the cameras. And I noticed that 80% of the time it gets it right, but sometimes it gives me bogus information, and sometimes it's just like 10% off or 20% off, but you never know when it's going to give you accurate information and when it's going to give you bogus information. And for example, it's like it has no complex, sometimes it cannot change like measurement systems or comparisons, like which is greater, and sometimes which is greater, it lists you as if it was smaller. So sometimes it reverses the relationships between between the concepts or between the numbers or values you are looking for. So that's why what I suggest, that if you are into AI or want to play around with AI, to use it as for doodling, to give you ideas, to kind of like help you build your draft version 0, and then you have to do the fact checking. You have to do each and everything that AI lists you must double check, especially if you want to build an amplifier for you, and there amplifier must be safe, so that it doesn't electrocute you and doesn't burn you down or doesn't burn the house down, and it also should be operational and stable, and AI is utterly incapable of doing that in a reliable method at the stage where AI is right now. So right now what AI can do is give you like a ground zero approach, which I would say almost as good advice it gives you as when you go on a forum and ask it on a forum and you look at the first 2 or 3 responses from the least experienced users. It will be about the same usefulness as that. But when you go on these DIY forums, you're also going to get responses from beginner users and also from expert users, and you'll have a billion times better chance of having someone recommend or design you towards that amplifier schematics on a forum than having AI do that. So at this point, what AI did is gave us a fun starting point, and yes, 12AX7 EL84 5x3 with a 5K output transformer, cathode bias, 250 transformer for the power transformer is a good starting point to get to build for yourself an affordable, simple, single-ended amplifier running in triode mode. And I think that's the gist of it, but you need an expert to parse it out, to double check it for you and tell you what you can take from AI's advice and what is outright dangerous and would make the amplifier wrecked. So based on the advice, the schematics it drew, it's completely useless. Oh no, actually it's not useless. I think this is an amazing design. I think you could put it like, I should maybe like print it out and put it on the wall as just fictional fantasy science fiction art. It's, I think in a movie as a prop it would be like a really fantastic, but it has no connection to reality. So thank you for tuning in. I hope it was really educational for everyone to get into using AI for amplifier design. Have an amazing day. Bye bye.